Hello, welcome back to this module. Here we're going to be discussing the ANOVA test, the one-way ANOVA test, and going over the assumptions and some of the math behind it. Starting off, the ANOVA test is a difference between group means when accounting for the variance within the groups. So you want to find if that difference between the means is statistically significant. And there has to be more than two groups for this test to go on. So generally speaking, the assumptions of this test are that all groups are independent, so you don't have time 1, time 2, and time 3 of the same participants. You have groups of people from countries or whatever. The data needs to be normal. However, this test is pretty robust towards handling relating to kurtosis. Generally speaking, we need to have homoscedasticity, which is equal variance between cells. But again, the test is relatively robust to that, and there's a check built in, and there's ways to fix that relatively easily. Something that is an issue that you may come across is that your group sizes need to be relatively equal to run an ANOVA test. So you will need to have equal size of groups. So this is a problem with the data set that we are going to be working with. However, I've come up with a few ways that we can look at it and view the ANOVA test, still with having equal cell size. That's equal number of peoples in group. So to start off, going into the math, we are going to be looking at differences among people from different countries on acceptance of political violence. So within our data set, there are a lot of people from the United States and very few from other countries. But there happens to be a population of 5 from the United Kingdom, Australia, and Canada. And these are their scores on political violence, the acceptance of political violence scale. So these are from each of those countries divided up. So the ANOVA test is calculated by the F statistic. So this is calculated by the mean square between groups divided by the mean square within groups. So it deals with a sum of squares a lot. So the mean square within groups is the sum of squares divided of the entire it is the sum of squares of the variation in between the different groups. So in between the United Kingdom, Australia, and Canada, that's the mean value between the differences between the two groups, and the mean square of within groups is the error, the mean square of the value that arises from the changes within the group. So it accounts for the difference as well as the variance. And this is calculated kind of very simply. We need to find, for the mean square, the mean square between groups, we need the sum of square between groups divided by the degrees of freedom between groups. And that can be calculated. We find the sum of squares between groups. And the mean square within groups is the sum of square within groups divided by the degrees of freedom within groups. To start off, I calculated the total sum of squares for the entire data set, and that's just each instance minus the population mean over here squared, and then the sum of that. You'll see that the sum of square total equals just a little bit over 26. It can be found right here. And then I looked at the sum of squares within groups, which is the each instance minus the group mean, the specific mean of the group, squared, and then finding the sum of that. and you can see that was almost 22. Now the sum of squares between groups can be found very, very simply once you have these two pieces of information. This is because the sum of squares total equals the sum of squares between groups plus the sum of squares within groups. So how I did that was I just subtracted sum of squares within. So you just subtract the sum of squares within score from the sum of squares total, and that gets you your sum of squares between. So you can see in the formula, that's what I did. So here is the calculations of the mean square between groups. As you can see, the group number, there are 3 groups minus 1 to get the degrees of freedom between groups. That equals that number, and then the mean square within groups is calculated right here. And as you can see, the degrees of freedom, there's the n of this subset is 15. Subtract the number of groups, 3, we get 12. Then dividing those, we come up with an F score of 1.31. Now this is, if we were to look on a critical F value scale, we would find that this is a non-significant result. So that the difference between the mean scores between these are there is no statistical difference. And you can look over here and see the mean scores are relatively close. So this is probably what we would expect given the mean scores that we have and the standard deviations associated with these scores. So this is a really quick, rough and dirty overview of the ANOVA test. I'm sorry if you got confused. Just know that it deals with the sum of squares and finding the difference between the means when accounting for the variance. SPSS makes this really easy to do, and that's what we're going to focus on in the next module. So I will see you there.